Fieldwork exercise number 2. Taping over smooth or level and unlevel ground. Introduction. The common method in measuring the distance is by direct measurement with a tape. The distance measured with a steel tape is much more precise than the distance obtained by pacing. The precision obtained depends upon the degree of refinement with which the measurements are taken. Ordinarily, taping over flat, smooth ground with a steel tape or chain, divided in thousandths of a meter, provides a precision of 1 in 3,000 to 1 in 5,000. When the ground is fairly smooth and the ground cover vegetation is light and low, the effort required to measure the distance between 2 points or to set a point ahead of some required distance is very minimal. If the ground is not too rough and hilly and in general considered as gently rolling, the taping procedure required would be slightly more difficult than that required for taping on flat ground. In this fieldwork report, the surveyor will learn techniques and principles as well as some considerations to be made when taping a level ground and uneven ground. Objectives: 1. To develop the skills of taping the distance on a level ground where the tape is fully supported by the ground. 2. To acquire the skills of taping the distance on an uneven ground where the tape is only supported at the ends. Instruments and accessories needed in this activity are range balls, measuring tape, markers, either chalk or marking pins, and plumb bob. Procedure in taping over smooth or level ground. 1. The professor assigns the accessible and unobstructed course to be measured by the surveyor on a level ground. 2. Mark the endpoints by a chalk if it is on a pavement or by marking pins if it's on soft ground, and designate it as endpoints A and B. 3. A range pole-man holds the pole vertically and steadily during the entire taping procedure at B to keep the complete taping process aligned and straightened. 4. The tape is stretched out on the ground on a straight path along A to B, where the zero end is held ahead. Note that zero end is nearer B than A. The rear tapeman is responsible for giving the signal to the front tapeman if his path is straight, while the front tapeman is responsible to pull the tape taut once the tape is aligned already. 5. The front tapeman gets a pin and sticks it vertically on the ground exactly opposite the 0 meter mark of the tape. 6. Rear tapeman holds one pin and the rest of the 10 pins are held by the front tapeman. 7. Both the front and the rear tapemen lift simultaneously the tape and move forward along the line AB to measure the next tape length. By now, the rear tapeman holds one marking pin which signifies one tape length. 8. The procedure 4 to 6 is repeated to complete the next tape length measurement. Make sure that the rear tape man pulls the pin before lifting the tape to move on to the next tape length. The rear tape man holds two marking pins to connote two tape lengths have been measured. Repeat the same process until all the pins being held by the front tapeman have been used up, which signifies one tally, where one tally is equal to 10 tape lengths. After a tally has been accomplished, the rear tapeman returns all 10 pins to the front man to proceed in measuring the length of the course. Note that one round is when all the 10 pins are now being held by the rear tapeman. 10. Repeat the same procedure. If more than one tally is needed, Upon reaching point B, the partial length must be measured accurately up to centimeters by the rear tape man while the front tape man is holding the 0 mark at B, and both of them are holding the tape dot. 11. The number of small pebbles in the rear tape man's pocket now indicates the number of tallies made, and the number of pins in his possession indicates the number of additional tape lengths. This is recorded in Table 2.1, taping over smooth or level ground. 12. To compute for the total distance, get the total number of full tape lengths and then add the partial tape length to the product of the length of one full tape length and total number of full tape lengths. 13. To compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. 14. To get the relative precision, determine the probable error of the mean, then divide by mean distance and reduce the numerator to unity to determine the relative precision. Procedure on taping over uneven ground. 1. The same course is measured, but this time, the tape will be unsupported by the ground and must be held an eye level distance above the ground. 2. Both the rear and the front tape man hold a plumb line over the center of the hub. 3. The front tape man must hold his plumb line an arm length away from his body for the rear tape man to clearly see if it is aligned in the range ball at B. 4. Once the rear tape man approves the alignment, the front tape man holding the 0 mark pulls the tape dot and drops plumb bob on the ground. This will mark the ground with a dent to guide the front tape man where he must place his marking pin. 5. This is to be done continuously until point B is reached. Note that the partial length must also be measured as in procedure A. 6. The course is measured back and forth to complete the number of trials required by the professor. 7. Tabulate the data in Table 2.2, taping over uneven ground. 8. To compute for the total distance, get the total number of full tape lengths and then add the partial tape length to the product of the length of one full tape length and total number of full tape lengths. 9. To compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. 10. To get the relative precision, determine the probable error of the mean, then divide by mean distance and reduce the numerator to unity to determine the relative precision.